Hello everyone, welcome back. So this time we're actually going to jump into our temperature scales. And that's where it gets a little bit more difficult and sometimes slightly confusing for people, so let's try it out. Okay, so relative temperature is what we're going to talk about first. Now, relative temperature is simply saying I'm measuring the temperature relative to something. Now, what am I measuring it relative to? Well, on the Celsius scale, that's the SI or metric measure of temperature. We measure it based on the freezing point of water. The freezing point of water is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius. And it's not an accident that's the case. That was set to be that way. 100 was the boiling point and 0 was the freezing point. They wanted that, that's what they went for. So, it works. But you can see that you can go below 0. You can have negative temperature. Can you have negative distance? Can you have negative mass? Can you have negative energy? Now, if you've watched a bunch of sci-fi, you've probably heard of negative energy. It's a good sci-fi trope, but it doesn't exist. There's no such thing as negative energy. All those things are really only positive quantities. Can you have negative velocity? You can have that, I guess, because velocity has a direction, but even then your speed is always a positive number. You can't have negative speed. It's just based on direction. So relative temperature is simply saying that 0 is not really 0. 0 Celsius is not 0 temperature. It is just the point we were going to. That's where I started my scale, and so I can go below that. Negative 273 Celsius is actually technically where you hit 0 temperature. And we'll talk about that next time. Okay. So remember, relative temperature is relative to something. Now, what is Fahrenheit relative to? Because you know that the freezing point of water in Fahrenheit is 32 degrees Fahrenheit. And the boiling point is 212. What were they going for? Was this person crazy? He wasn't crazy. Fahrenheit, there's actually a man named Fahrenheit. He created the scale based on the temperatures he felt people would actually experience. 100 Fahrenheit was actually supposed to be body temperature. It's just over the years, they realized that, with his measurements, 100 was body temperature. However, over time, we realized that, body temperature is about 98.6. And they're not going to change the entire scale to fix that. Okay, so that was the first thing. And you're like, well, where is 0 from? Well, 0 was actually the freezing point of like an icy, salty slush. So frozen seawater. It's not 100% what was going there, but more or less frozen seawater. So what he thought was this is a good range, 0 to 100, is a range of temperatures that most people will experience. If you go to the Sahara, you'll find definitely hotter than 100, even on a hot day in North Carolina. However, for most people, 0 to 100 would encapsulate the temperatures that they are going to experience. 0 to 100 Celsius is way more than most people are going to experience on this planet. Because there's no place on this planet that naturally, besides like a volcano, would have 212 degree Fahrenheit temperatures. Okay, so get the point here. You get what's going on. They both had ideas about what important scales would be. So these are temperature scales. Okay, thing to remember is that 0 Fahrenheit is not equal to 0 Celsius. It's not the same amount of temperature. Because you see that 32 degrees Fahrenheit right here, sorry, I used my mouse, is the same as 0 degrees Celsius. Also, 0 Fahrenheit and Celsius, not 0 temperature. We talked about that last time. It can go negative. You already see that right here on the Celsius scale. And it can most definitely go negative in Fahrenheit as well. And because these are relative temperature measurements, you can't use a unit conversion to convert between the two. You have to use an equation. So whatever my temperature is in Celsius, I just plug that number in, forget the units, multiply it by 1.8, and add 32, and I'll get Fahrenheit, or I can solve the other way to get Celsius. Okay, so don't forget that. There's only one case where that wouldn't be the case. That's if you're not given a temperature, but instead a temperature change. It's a difference. You know the difference. This is for converting temperature. It's like somebody says, oh man, it's hot outside. How hot is it? They're like, it's 105 degrees Fahrenheit. And they're like, I'm from Great Britain. What is that in Celsius? Oh, we type it in there. It's something. But if I were to say, what's the temperature change today? You're saying, well, it's 10 degrees Fahrenheit hotter than it was yesterday. And somebody says, what would that be in Celsius? You do not plug temperature change in here, okay? Delta T does not go in there. For that case, it's actually super simple. All you have to do is this. That's it. You're done. When you're doing temperature change, you can do a unit conversion. So it's just Celsius is bigger. So 1 Celsius is 1.8 degrees Fahrenheit. That's all you have to do to convert a temperature change. Okay? So if you see some crazy units and it's like mass per degree Fahrenheit or something, you can use that unit conversion. If you just see degrees Fahrenheit by itself, you can't. You have to use an equation. Okay. So don't forget that. It's very important. Relative scales relative to the freezing point of something, but not relative to zero temperature. Next time we learn about absolute scales, which were made to fix that issue and put the point where it should be at zero temperature. So I'll see all of you next time. Hope you enjoyed this. Bye-bye.